Well, welcome to chapter 20, where we talk a little bit about the use of land and the connection again to geologic hazards. We made some connections between environmental policy and geologic hazards. Some hazards have been regulated both by federal and state. And then, uh, we can talk about some of the other sort of examples of geologic hazards and unintended consequences. So first we'll talk about U.S. land use options, and then how we classify the use of land. Mainly we'll focus here on the kinds of land that we have within this country. Developed land's fairly small. Water area is also a fairly small piece of the pie here. But what we see are rangeland, so this would be open land run or governed for or allocated to potentially grazing, forest land, cropland, and then the federal government also has a big chunk of land within the United States. Land use comes in multiple ways. There's always things like single use, but nowadays we tend to move towards multiple uses. That's one approach to this, and so we got two or more purposes here. This would have been federal government land, not used for much of anything, and now it's allocated to sort of grazing of cows or rented some small lease for people to graze livestock. Sorry about that. In this case, so this is sort of a single-use scenario run by the federal government. If we come up here, though, we have a farm and it has wind turbines on it. It's an example of multiple use. So it's simultaneously we're getting two things out of it. When we come back to the federal government, what you don't see is that a lot of times in rangeland like this, what you find are things like hiking, fishing. You find outdoor recreational vehicles being used in this kind of rangeland as well. So strictly speaking, that's dual purpose or multi-purpose use at the same time. Another approach to this is what we call sequential or multi-use. This is an image from Google Earth, and we're looking at the San Gabriel River as it comes out of the San Gabriel Mountains here. It's coming down into a region here where we've got this big U-shaped thing. That's a flood control structure, and since the San Francisco Dam ruptured in the 20s, this has been put into place here because we have two large reservoirs up here. If those dams were to break and those reservoirs to spill out into the valley below, this would presumably be available to stop that from happening. And it turns out I grew up, somewhere right over here in this region. Oops, daisies. Not too far from, you can actually see the racetrack and some of these other features from space. But I grew up in this region and would sort of ride my bicycle over to this thing from time to time and ride down the San Gabriel River, which has been all cemented up, so it doesn't have any erosion of its walls. It's a big flood control channel now. So this is an example of multi-purpose use. So it's both a recreational area, but a flood control area as well. And if we zoom in on it a little bit here it is blown up. This is a big dam that's going to hold water that would come down through here. And there's a lake and stuff in here already for people to use. If you come off to the left side, you see bodies of water. Those bodies of water are actually quarries. And this is a place called Irwindale. And at some point, I think in the 90s, they were considering moving a football team out here and building a stadium in one of these quarries. But if you look right here at this little square patch, this was also a quarry. It was turned into a landfill in the 80s and 90s, I think, and then filled up close to 2000. They covered it over and built a racetrack on it. So it's an example of sequential use. So here we have multi-use, right, where we've got a flood control system in a park with a recreational facility. Here we have sequential use where they put this Irwindale racetrack on top of an old landfill, which used to be an old quarry. Okay? And you can see in this area, look how densely populated it is, right? There's not a lot of extra land available. So this is one of the reasons why sequential use or multi-use is popular, especially in areas that are already so heavily populated. Here's Meads and Ross marble quarries. These have been turned into recreational lakes. Notice there's not a lot of homes and stuff all around here. So in this case, it is an example of sequential use. They dug the quarry filled up with water, and now it's a kind of lake facility for canoeing or for boating or for fishing as well. But it is not an example of one that's in a densely populated area. And it's the key here is that it becomes more useful when you have a densely populated area. Here's an example of sequential use. This is Mount Trashmore in Evanston, Illinois. So just north of where I currently live. This is a landfill that was then covered over and has become a very popular sledding hill in the region. How do we determine how land is used? Well, the tool of the day is satellite imagery. We use satellites to collect elevation data. We use them to make digital elevation models. But we also collect information about the kinds of ground cover that we have. The presence of water, the presence and type of vegetation, the presence and type of rock as well. And this is done using geographical information systems, which combine the use of satellites and computational software. So Esri is a company that puts out software called ArcGIS, which you may or may not have heard of, that we can use to build up sort of layers of information. So your city will have a system like this that will focus on gas mains, gas lines, water mains, sewer mains. All these things are probably in ArcGIS software and mapped out throughout the city. We have building data, we have vegetation data, and then what we do is we layer it all and stack it. Okay. So here's an example of a map showing land use. We have open water, forest, mixed forest in purple, forest, coniferous, developed or barren land down here in the southern part of this region of New Hampshire and Vermont. But lots of it is deciduous forest, as you can see, and non-forested uplands. Okay? Each of these little pixels in here represents essentially a little chunk of data, right, that has been compiled in a false color image mosaic. So how do we go about doing that? You can see here's one blown up for the US, irrigated cropland and pasture, cropland grassland mosaic, and sort of this beige color. Oops, daisies, having some trouble with my mouse up here. Evergreen needleleaf forest, so the kinds of vegetation are being shown here across the U.S. Now, vegetation, geologic hazards, infrastructure, all these things would be things we'd be interested in with land use. So here's soil type, water drainage, okay, and slope steepness. Okay, we've gridded out the area, and we're showing areas where we have clay-rich soil here, we have water-related drainage, and we have steep slopes. We then fill in this and turn it into a quantitative grid. So it first starts out as the presence or absence, right? This is binary, yes or no, it exists. And then we bring it down to a second level. So we go from mapping it and putting a grid on top of it of some designated size or scale. We then determine whether that thing is there, present or absent. It doesn't exactly say how good it is, how much it is, how fast it's moving, just that it is or it isn't. We can then say yes or no. We then come down and turn that grid into a quantitative value. And so you'll notice here we've given the yes value a 1 for clay soil, the yes value for waterway drainage a 2, and the yes value for steep slopes a 4. And then we can overlap all three of these maps and sum up the values here. So for instance, in this upper central block, it would be 4 plus 2 plus 1 gives us 7. That means all the features are present. And you need to use a number system in this case that gives you different combinations of soil or soil plus water or water plus steepness of slope or clay plus steepness of slope or all three. So any three of those things may or may not be present, and we need a number that is unique to the things that are present in that area. And so that's what that key is down here. We then take that number, we give it a color or a symbol, and in this case we plot it up on the map. In the terms of geology, what are we interested? What would be relevant with regard to land use? Active landslides, right? Steepness or steepness of slope, so the potential for landslides or just in general creep, right? So the expansion of soil in a region, cliff erosion in this case, and then the presence or absence of faults in a region. Those would be 4 examples of geologic things we'd want to regulate, think about when we're talking about land use. Okay? Now, we've also taken this to the extreme and used numerical modeling to evaluate these data sets. This is the Central Valley, and what it's showing you from 2011 to 2015 is area of cropland. So you can see the area of cropland in green. Some of it comes out of the valley, and then you have this blob down here. Okay, and then annual idle areas. You'll see down here there's a little bit of red, in there, and there. And then when you come over to September 2015, you see more red. You see extensive red because California is in a drought. So not extensive, but a wider zone of red that is growing. And this is done through both the use of a collection of data, satellite data, which can tell us about moisture content and the kinds of potential kinds of vegetation that are, or the density of vegetation that's in an area, and then combine that with numerical modeling to estimate these kinds of changes. All right, so that wraps up my summary of land use. We talked about ways in which we can get multiple uses or sequential uses, and a little bit about how we go about figuring out what we're going to do with the land and what's happening to it, in this case, how cropland is being used.